Okay, for example.
Yes, they only care about your EAP score.
For example.
Oh, so they not got.
I got a
They
7.
only see.
I think they only see your final EAP score. Guys, we'll continue with the math.
Student travel. 17 euros, 3 application.
Dude, the math. Come on, take out pen and paper. Can I just have something to put under the...
But at that time he's really focused.
When you finish, tell me.
He's really focused at that time, like if he is asked and then when I answer he.
Yeah, he just
It's like he really understands.
He tricked you. You fell for that? Oh, wow. You shouldn't believe Dennis. And what did Dennis ask you? Hey, what did Dennis ask you? Did he seem happy with your answer?
He was just shaking his head. No, he was smiling.
He always smiles.
Okay, we can stop that now. Hang on, what's that? We have a very easy lesson to start with, which is good, because your brains are probably a little bit dead right now. So can you write down secant, cosecant, and cotangent? Come on. Why so? What took you so long to get ready? I've been sitting here chit-chatting about your presentations. Okay, are you all ready? Great. So, I think some people already know some of these terms, secant, cosecant, and cotangent. Does anybody know secant? Secant?
It is the 1 over sine.
You had a 50-50 chance and you blew it. 1 over cos.
Right.
No square. No square. So secant is 1 over cos. Now please don't think this. No. That is not the same thing as this. It's not. Couldn't be more different. Because here this does not mean 1 over cos. This means 1 over cos. This is not the same thing. Okay, so please don't think that. There'll always be some idiot that will think this. Don't think this. Okay? You be good now, Yafia. You're only back.
I wasn't sick. I wasn't fasting.
Fasting doesn't slow you down.
Of course it doesn't.
You're fasting or not?
Yes, sir.
Yes. Continue. You have this. The next one, cosecant, is defined as.
I know.
Go on, Faisal. What is it?
1 over sine.
That's it. And then lastly, cotangent, cot, that is.
1 over sine.
Music is not necessary. I know it makes it seem more exciting. And what I could do then, I could put it like in some kind of cinema mode where we have no, I was thinking like having like black captions on the top. You know, just make it a bit more cinematic. Yeah. Possibly special effects. Could be some kind of Terminator or something here. You know? Numerator, denominator, Terminator.
Doom.
Doom. Great. Right, you got those? So these are the basic definitions, and we want to have a look at some calculations. If you look at your calculator, you will notice that you do not have secant, cosecant, or cotangent. So we just want to practice some basic calculations. So let's just calculate secant 30 degrees. Well, we have to write it like this because our calculator doesn't have secant. So can you hit in 1 over cos 30 and what will we get? 1.15. Are you in radian mode?
No.
Okay.
6 points.
Caramba.
It is 1.14.
1.154.
This is 2 root 3 over 5.
Okay. Can you calculate cosecant 45 degrees?
1. 0.5? 1 over 0. No. No, side cosec.
Right.
Wow. Nice.
Yeah.
Nice. My boogers need calculation.
Oh my goodness. Right, so, you know, that's gonna be in the YouTube video now. If someone turns the captions on, they'll see me talking, and then in brackets, background student says.
Fat booger, nasty boy.
Yeah. Now I'm gonna have even less likes. Right. Cotan 60, please. Can you calculate? So that's the basics. That's okay. But now what's more difficult, and I want to see if you can figure out how to do it, I want the inverse calculations. Can I scroll down? So let's see who can figure this out. And actually, you have done enough maths to figure it out. I want you to calculate cotan inverse 2. That's an example. And now before anyone says this is not 1 over cotan. Because I know somebody was thinking, oh, I'll just type in 1 over cotan 2. It's not that.
It's simple,
Okay, do it.
I'll give you a
I'm
little.
just guessing.
I'll give you a little hint. It's actually kind of helpful to think about it as like this, and you're trying to find x. Now you see, that was enough for Lee. No.
Oh. Yes.
You got an answer? No. I don't think so.
I'm sick.
I know you're sick. I know. I'm not judging. Right. Who knows what to do?
Make it cotan x equals 2,
Good. Cotan x equals 2.
and then 1 over tan equals 2, and then it's
And then what?
1.
1. No, 1 over 2 equals tan x. So x equals tan inverse. Aha! That's what the answer is, Faisal. Maybe we should write this down. What is that answer, by the way?
26.56.
Bro. That was the answer that I gave you.
Was it?
Yes, I think.
Tan inverse 1 over 2? You gave me 1 over tan 2. You gave me 1 over tan inverse 2. I don't think you gave me tan inverse 1 over 2. Did you?
No, see,
Did you?
your answer is 26.6.
Yeah?
My answer is 26.6.
No, bro.
What are the possibilities?
No, bro. You was wrong. Okay. Do you write that down? What lesson should this remind you of?
Trigonometry.
No. Well, it should because there's a tan in it, but what else? The lesson where you have to find the inverse. Yeah.
There were a lot of lessons we had.
There was one lesson where we had to find the inverse.
Question.
Yes, sir.
The first step, what did you do?
This step,
Yeah.
I made x equal to what I want.
Yes, and then?
I put cotan on both sides.
But can you multiply by just cot, or do you have to multiply by cot something?
It's not really a multiplication, you are taking the cotangent of both sides. In the same way you take the e or the log of both sides.
Identities?
Yeah, cotan A equals cotan B if A equals B. Scroll down. Now that you have the idea, I'd like you to try this one for me, please. Can you try and give me cosec inverse? Let's go with 2 again. Problem? Try not to collapse in my class.
The only thing that I hate when I get sick is when I get the flu. Other things is fine, but flu no.
Seems legit. Anyone else get an answer? Yeah? So again we have x equals cosec 2. So that means cosec x equals 2. 1 over sine x equals 2. 1 over 2 equals sine x. X equals sine inverse a half. So x equals 30. Yeah? Okay, let's go on to something a little bit more difficult. Can I scroll down, Andrew?
Yes.
Yeah. All right. Yes. Okay. So the last thing I want to show you, I said this lesson was very easy, is plots of inverse functions, in particular these ones. I wonder is the next lesson hard? Compound angles. Yes. Okay, can I scroll down? So, you remember before the holiday we had a look at y equals fx and then its inverse function inverse x. So for example, just as a quick refresh, can everybody give me the inverse function here? Just take a minute to work it out. If you forgot how to do it,
Minus
X
3.
minus d over 2.
yes. Now which way did you do that?
Make x equal y and then
Yeah,
change
and change the subject. So here the inverse function would be x minus 3 over 2. And we had two ways to work this out. What was the other way? Using those bubbles.
Oh,
you move one by one.
the
Yeah.
thing.
The kid thing, yeah. So that's the inverse function. But we'd like to know, if I know this graph, let's just say it's something like this, is there some way to work out what the inverse graph looks like?
Yes, of course.
Because it'd be a very short lesson if I just said, and there's not! And we finish there. Of course there is some way. We have to think about what do we need to do to change the graph from the original to the inverse.
I tell you.
Go ahead.
I'll give a tip so that they will give you the answer. When we change the graph to the function to the inverse of the function, we make x as y and we solve. So, if you
Yes.
make X as Y and you draw with X reading and the Y plots,
Yes.
you'll get a different graph.
Yeah, no, I know this.
So, but,
That's just stating the obvious.
but,
Yes.
yeah, so ask them now.
Does anyone know how I could make the inverse graph?
What I said was right. Think about it now.
Anyone listen? So what he was basically saying is you change X to Y and then solve for Y and then find Y and then...
Yeah, but how can I change the graph
Looks like.
without having to do any calculations? Go on, Wong, yeah? Which line? Yeah, so Wong has, I think, the idea. So let's take an example graph. Let's say this one here, y equals x squared, or in other words, fx equals x squared. What's the inverse function here?
Root X.
Root x. Yeah. Now, Wong, what's your idea for finding the inverse graph? You said first draw the line y equals x. So I'll just put it here. Now, what next,
It's a
Wong?
reflection on the line X, Y.
What? How?
reflection. Mirror. You reflect it
Mirror through what?
to the line.
Yeah. So in other words, it's like you spin it around this this line, and this is the inverse function, which in this case is square root x. Yeah. Now, if my graph program opens, I can kind of. Actually, I didn't think it.
So it goes like this.
No.
Which way?
Draw it. Draw.
You get the idea? Look, sleepy.
Draw main
Sleepy
graph,
one, sleepy
but
two.
you draw the line equals X, Y. The line of X equals Y.
All this non-fasting you're doing is making me tired.
This will go to alpha 5 seconds.
You reflect on this line.
Can we do another example?
Yeah. It will be
I know you're not.
here sub, so this will be reflected here.
Y, X. Okay, let's take something a little bit more difficult. Let's take some cubic.
Yeah, so it's like what there is not.
Yeah.
So it's like an X.
No.
Let's see what
No,
you turn. No, let me see.
No, wrong.
Let me see.
Like this.
Yeah, a little wrong.
That's what fits into.
Yeah, I told you it's wrong.
Oh.
Guys, can we do this one now? So this is y equals fx, and I want to draw the inverse function. Well, first let's draw the 45-degree line in, huh?
So it's always like an X on the 45-degree line.
Yeah. This is going to be a bit hard to draw.
I believe in you.
Yeah. Well, hang on.
A big one and done.
Yeah.
Wow.
That's the inverse function.
Remind you of anything?
No.
It's hard,
What is that?
Guys, I don't know what you see when you look at this.
Coca-Cola glass bottle.
Yeah, of course.
Really?
Yes.
It doesn't look like anything. Okay. Did you get the idea? Yeah? So let's try something else. How do we draw... If I know this graph, how can I draw this one? Which is not the inverse, but it's relevant for this lesson because we're looking at 1 over sine, 1 over cos, 1 over tan. So does anyone want to explain how I can go from, let's say, I don't know, again, let's go with a quadratic or something.
Is left in the x-axis or y-axis? The x-axis.
Final answer?
X-axis.
Wrong.
Axis. Yeah.
No,
That's the x.
Thank you. I know which one's the x. Reflect on the x, no.
reflects on
So it doesn't
y.
become
No.
exact, like a flat face?
No, that was that face.
What do you want it to do?
I want this graph. No, in this graph.
Reflecting the y?
It's not
No.
an inverse.
It's not an inverse and it's not a reflection. So basically, when you calculate 1 over something, the values which were big are now small, and the values which were small are now big.
Yeah.
And the which was 0 is now
The biggest.
not the biggest, which is infinity. So big becomes small, and small becomes big. So because this was big, it's now small, and this gets smaller here. So now it gets bigger. And then what happens when it gets to 0? It goes up to infinity. So the graph looks more like this.
It's like one of these that we saw.
Yeah. So no reflection, nothing like that. The big values become small values, the small values become big values, and 0 values become infinite values. Because this graph was positive at the start, it's still positive at the end, because 1 over x doesn't change the sign.
Is that how you present infinity?
Yeah, just put a little arrow pointing upwards. So let me show you that. Here is the graph x squared. And then we want to draw the graph 1 over x squared. And it's like this. Can you see that? And then let's have a look at a cubic and an inverse one. So here is fx, I don't know, x plus 1 cubed plus 3 or something. I don't know. Let's draw fx. What the heck? Oh. Whoops. Computer error. Caused by the user. Okay.
Computers don't make errors.
True. Right, there is my cubic. Let me do that. Oh, no. Close, good enough. So I want the inverse function. I'll use the program to get the inverse. Who remembers how to get the inverse? What do we do? No, if I want to calculate the function. So I make x the subject. So in other words, what I do is I solve this expression, but I solve it for x. And I get this function here. Yes? And then I can plot that function. I think this might be too difficult. Let me just, it has I in it, which makes me sad. Does it all have I in it? Oh no, the last one doesn't, okay. And then I'll just change the y back to an x. There we go. Okay, so now I'll plot this. So can you look, use your imagination. Can you picture the 45-degree line here? And can you imagine it being flipped around the 45-degree line?
Where do you imagine it?
The 45-degree line will be going... Actually, you know what? I'll add it in for you.
Does it have to be positive?
No, here it is. Right, there's the 45-degree line. Can you imagine it being flipped around this line? Okay, let's see the inverse graph. Ready? Oh, sorry, wrong one. Let's try it again. Ready? Yes.
What?
Now, you might be wondering what's happening here. And the reason is, this function really doesn't have an inverse because it's not one-to-one. So the program has cut away some of the answer. You remember when we did this lesson, when we did cubics, were cubics one-to-one? No, they weren't one-to-one. Do you remember that? So when you had a cubic and you wanted to make it one-to-one, what did we have to do? We have to cut some of it away. So for example here, I'd maybe cut away this piece. and just left with here and here. That's what the program is doing here. That's why it looks a bit weird. I'll pick another function that's easier, okay? Let's go with a linear. Okay, what's the inverse function here? I think it's x minus 4 over 3. Yes? Okay, let me draw in my line. Right, now can we imagine it being flipped? Let's have a look. And you can see it's flipped around. That's the inverse function. Can you see that? We'll do one more, we'll make it a little bit harder now. So now for today's lessons, let's do cosecant. So what is the formula for cosecant? 1 over sine x. Okay, let's draw this. So that's 1 over sine x, cosecant. Now, why is the value so big here and here for cosecant? Yeah, so why is it big here and here?
0.
Well,
These are the, yeah, the points.
exactly, let's draw the original sine. So you see when sine is small, 1 over sine is big. And when sine is big, this one here is smaller. When sine is small again, then 1 over sine is big. Yes, can you see that? Yeah. So what I want you to try and draw, and I know it's going to be hard, I want you to try and draw the inverse of this cosecant one. And I'll help you by putting in the 45-degree line. Does that help? Do you know what? Let me delete the sign, so... and then put this one in. Okay. Now, before you draw... wait, listen. Before you draw, is this function 1-to-1? This cosecant function, is it 1-to-1?
No.
No, because when I draw a horizontal line, it passes twice. So I need to cut some of the function away. So in the exam, usually they just want you to use this piece and this piece, and to cut everything else away. So let me cut that away for you.
Well, what piece? That one?
What, huh?
Which piece is it?
From here to the left, and here to the right, because it's not 1-to-1. Because when I draw a line here, it crosses twice. So we need to cut this away, and we need to cut this away. So in other words, in the exam, they just want you to do this part. Okay, can you try and draw that, please? I want to just make sure you can get the inverse graph here. One, 2, 3. I count 3 sequence students. You were looking a bit sleepy too, you know?
I'm really sleepy now.
Yeah. But clearly you are much stronger than these boys. These so-called going to the gym, healthy, strong boys. Let's see. You said you drew?
This graph possible. Like a next sign.
Wow.
Like a bird. No.
Not like this.
That's the same as this. No, but I want the inverse. So I need you to flip it around. The blue line.
Is there a y equals x line there?
Close. Not too bad. Not too bad. Not perfect.
And so this goes there.
Yeah, it's like you spin it around.
I don't know like what to do with.
Here. No, stop. I'll do it.
I know.
You know. No, look. Use your imagination.
Yes, I am.
Flip this around. So this would be like here.
Yes.
And this would be like here.
We're gonna do this one first.
Huh? Imagination is hard. Yes.
So like this.
No imagination, Omar.
So this point is like this.
What? No. No, this just gets flipped around. It looks maybe the same.
Oh yeah. Like this. Like this. Okay.
Yeah. No. Just like this. Let's see. Where? What? Wait. No. Firstly, this should be down here because it flips under the blue. Guys, none of you have imagination.
I do.
Yeah.
Flip this over. So. Now hang on. This will be here. And then this one will be something like this.
This one. Can I try?
Go on, try.
This one. This.
Yeah. Let's see.
No.
Yeah. No, yeah, like this. Yeah.
Like this.
I know I didn't say perfect. Did I?
This goes up here, and this.
No, it's wrong.
This goes there, like this way, because it flips. So this part comes like this.
This is
No.
Flips.
this is one of a kind, wasn't it?
Yeah, and then this. You see it rotates like this, so it goes like this again.
It's the inverse of sine. Got too crowded. Okay. In the exam, they like asking you to draw the inverse function. But there are other ways to draw it if you find the 45-degree line too hard, but I think that's the easiest way. Yeah? Let's have a look here. So basically what you're trying to do is get something which is like here over to here. Is there any other ways to do that without flipping it the way we were flipping it? It's like maybe you could rotate it or something else?
Yeah.
What do you think? How can we get, my question is, how can we get this from here to here?
180 degrees rotation.
Rotate 180? If I rotated 180, wouldn't that be like down here?
On that point, like on the point in the middle.
Here?
No, like on the line between.
No, we want to try and keep it simpler than that.
Well, what do we want to do exactly?
I'm trying to get this from here to here. So what we could do,
Make y-axis and x-y.
I know it's simple, keep it simple. If I rotate this 90 degrees, so if you picture rotating at 90, then this would be, my goodness, this is hard for me to draw, but, okay,
Like this.
like this? Yeah. And then, if you flip it around
Oh.
like that, it'll be in the same spot. Now, some people do it this way, but I find this way kind of confusing. I much prefer to think about this line, and then just swing it around that line.
Yeah, I think it's the next class is.
Yeah,
When
yeah.
you rotate it, do you reflect it in the...
Reflect it, yeah. Yeah. Is it?
Yeah.
Rotate and reflect?
Yeah.
If you say so.
Okay.
So let's test it out.
Reflect as in like just take the points and just like change them.
Yeah, let's test it out. So do we get the same answer when we do it using the 45-degree line? So when we use the 45-degree line, we should get something like this when you spin it around. Let's test. Okay, so first, rotate. And then reflect. Now, in fact, when you reflect, it's, in this case, it stays the same, yeah. So it's the same answer. Yeah.
When you reflect, isn't this on the other
No,
side?
no, no, reflect it this way. Okay. What I want you to do now, just as a... Huh?
Almost
OMG.
done.
We have a double class now.
Yeah, okay. Go to the next one.
I'll tell you what, I'll just... There.
Amazing.
Yes, indeed. There's only 3 questions, okay? Just do ABC now, just so I know that you can do it, of 1, 2, 3, and then you can take a break. So as soon as you have ABC, 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 then I'll give you a break.
Can we see one question?
I make it sound like an alarm clock, but that helps you wake up. If I just sit here going...
There's a part that we should use
Do
radio.
you know what I think might be funny? If we all just quietly like sneak outside when people are asleep, and then just see what happens, just wake up. How long was I asleep for? Good morning. We're doing questions. Like to do some? Well, that's how asleep Faisal was. I reckon we could have all snuck out. We're doing ABC. 1, 2, 3.
Well, there's a part that we use radio. Let's see.
What mode for C?
Radio.
Why?
Because it doesn't have the degree sign.
Correct.
And that's one now.
No. The first reason was it.
For C.
Yeah, why for 1?
Doesn't have
No, why?
degree. Doesn't have a degree. Degree means it's
Look.
degree.
Degree.
Yeah.
No degree.
Yeah, that's why radian.
Because it's not degrees.
And the first one is
What's your choices?
But it's not radian.
Radio.
Also not radian.
It's not degree, so it must be radian.
It's not radian, so it must be.
Okay, this is your point.
How do you know it's not radian?
How do you know it's not?
Because it doesn't have a degree symbol.
It's not have the p sign.
So, pi is just a number.
When we use radian, when we have
How simple. We use radians when we don't use degrees. And wait, when do we use degrees? When we have degree symbol.
We use radians. We don't have radians before.
Correct, we don't.
Yeah.
Yeah.
But we use radian when we have pi. When we have pi, we know we use radian.
No.
No?
Guys, what mode do you use on your calculator to calculate this?
Whoa!
Oh, mind blown!
Degree.
Correct, degree.
You thought
No, it also has the simple degree, but I mean only the pi.
What mode?
Radian.
Pi is number 3.5.
What mode?
Degree.
No.
No, radian.
You see a small circle?
What mode?
Degree.
Alright, number 2?
Can the answer be negative?
Of course, it can be anything. What?
There is a black hole in my stomach.
Faisal, there's a black hole in my heart. I
will
win. Like the word. ABC for number 2, please. When I was doing the test yesterday, he accidentally left one of the answers on the exam. Yeah, so I'm like, wait a second, this sounds like the answer, not the question. Like, alright, I'm just going to write this down. And then, the girl beside me, I could hear her saying to the invigilator, the answer's on the paper. And I want to say, dude, some of us didn't study for this test.
Oh, this is like God, no, stop there.
Shut up. Why would you say that?
We, in high school, we never wrote CSC for cosecant.
Well, there's different ways to write it. So you can write CSC, or you could spell it, Cosec.
Yeah.
What did you do?
Cosec.
You spelled it, yeah. I think in your exam they like to use CSC for cosecant. This is cosecant here. Cosecant. Cosec. Oh yeah, I didn't say. No, you can use your answer is going to be an angle, so you can give your answer as degrees or radians. It doesn't matter. So your answers may be different if you're in a different mode. Sounds like you're in radian mode, yeah. And sounds like you're in degree mode. And 58 is? No, 58 isn't the same as 0.57.
I got 33 points.
Oh, I better do it. Right, guys! I'm just going to do A, but I want you to try B and C. So what was A? Secant inverse? 1.1924. So that means secant x equals 1.1924. That's 1 over cos x equals that. So that means cos x equals that. So that means x is cos inverse that. And what did you get?
Basically, 0.0 over 0.576.
Yes. Okay, so B and C now, please. Really?
Oh, you put 1.924, not 1924.
Okay, can we go down? You have that? Oh, have you not done B and C yet? But you did A
Yeah.
before I did it, and you got it. Yeah, okay. Omar?
Yeah.
You fixed A?
Yeah, B.
Okay. Who has B? What did you get, Yusuf? In radians?
7 pi.
Yeah, okay, good. Okay, good. Now it sounds like you have the hang of it. So lastly, can you give me the graph for sine inverse, cos inverse, and tan inverse? In the last exam, I think they asked for sine inverse. Or was it cos inverse?
You already know sine inverse, so.
Do you?
Yeah, you just gave it.
Did I?
What's the last? Oh, no,
Dun,
no.
dun, dun, dun.
Over sine?
Yeah, which is not the same thing.
Do we have to go through all of these steps to get like the cross inverse?
No, let me get you started with the sine x, okay?
No, I'm talking about the two.
What's the
Yeah, you
domain
do, yeah.
that you want?
Just give it to me, oh my goodness.
To 90?
Yeah, just like I was thinking minus 90 to 90 will be fine.
Very nice.
So you know sine x looks like this. This is sine x. So what does the inverse look like? Well, we draw the 45-degree line. Guys, what's wrong? Come on, you listening? We draw the 45-degree line. So the inverse. Oh, it's ugly.
To infinity.
I tried to.
No, not to infinity. Only when it gets to 180.
No,
No, not
the
180.
shape,
No
the
infinity.
shape.
Oh yeah. Oh, I see it now.
I tried to do the rotation thing and then
So it's almost like when I said earlier I prefer the 45-degree line because it's easier. I might have been right.
No, I just
No, of course, that's ridiculous. Let's not consider that.
I want to know why it's different.
Shouldn't be. Right. Ready?
Yeah.
So the sine inverse function, I think will like be the red one here. Let's have a look. Too many variables. Oh. Yep. I didn't quite get it right because I think the 45-degree line, I should have drawn it more like higher on my picture. No, please stop. Whoa, way off. No, actually not way off. You just drew too much of the graph.
Oh, so it's this part.
Yeah.
Oh, okay.
Yeah. Guys, can you look again? Sorry. There's my line. So when I flip it, oh, it's kind of like this. Yeah. Can you see them? This one looks a bit better.
Yeah, this is why I asked for the domain.
Yeah.
I don't remember what happened after.
That's all we have to draw, like only that part.
That black line.
Did they tell you that you draw from -90 to 90?
Yeah. Doesn't really make sense after that, because then you get a weird graph like his. Show me your weird graph again.
Look at it, okay, for 10 seconds, yeah?
Yeah.
You just need to take the first mosquito.
Yeah. Yeah.
Just like literally, just flip it.
That's all.
It's more blue. Calm.
Right.
Don't tell me, can I make this stronger?
Not R. Kelly, not
Kanye
Kanye West, that's the other Egypt. Yes. He is a bit of a dog. Okay, did you draw that? He's just a class A dope.
Yeah, but then the thing is, he said,
That's a good
Isn't
song.
he one of these flat earth people? Or is it someone else?
he's the one that
He's the one that's married to
tried to go for presidency against Donald Trump.
Did he?
But like, even on Ellen DeGeneres, Ellen DeGeneres,
Huh?
the show Ellen,
Yeah.
he went and he was doing these like really weird things. He was also like, look, and then he started saying something like really weird and like out of context.
Do you know Kobe Bryant? The basketball player.
You don't know Kobe Bryant, what?
I don't watch basketball.
Yeah, but I don't watch basketball. I know who Kobe Bryant is.
Is he famous for doing
Kobe
stupid stuff?
Bryant. No, he's just famous for basketball.
No, he's like the next Michael Jordan.
I know Michael Jordan. Come on, give me some credit.
How much more do you want from me?
Alright, you have to watch.
Mr. Stephen, could
Yeah.
you write Cosec as CSC?
I might have said that when you were asleep, yeah, we had.
Oh,
In fact, I even said that's how they usually write in the exam. Yeah, yeah. I guess you didn't get that in your dream then. It didn't transmit, no?
Play.
Is it dirty?
No.
That means yes.
How much more do you want from me?
Oh, I know him.
How much more successful do you want me to be? More successful. How many records can my records break? More records. But are you a different animal and the same beast? What the does that mean, something?
That's Kanye West and Kobe Bryant.
No. Alright, take a break for 5 minutes and try to recharge. For people who aren't fasting, maybe you want to get some coffee or frappuccino. No, you'll stay awake. Too expensive, huh? Why don't you do a Faisal and like make your own coffee?